Hello everyone. In this presentation we are learning how to set up a CNC milling machine. These machines look like this. Some having this vertical spindle, some others you will find with the horizontal spindle, and that's how we uh, characterize them, and that's how they are different in design. So the first step when we are setting up a CNC milling machine is that we're going to hold our workpiece, whatever we want to machine. So sometimes we hold workpiece by using different work holding devices. One of them could be this what we call machine vise. Machine vise, this is the plain machine vise. So when we turn this handle clockwise, this moving jaw will move forward, and anything between these jaws will be held. If you turn it otherwise, this will move backward. So that's how you can loosen it and tighten it. Now, some best practices when we are using the machine vise. For example, if we are holding, this is my work log, and I want to hold it in the machine vise, we should be holding it in the middle and not on the end, because that way we will not have optimum clamping force on that block. So while we are machining it, it can go out or can move and cause an accident. Other ways of holding would be the V blocks, what we call. So V block with the clamp, these two you can see, and those are the plain V blocks. Here you can hold on a square bar with this clamp, and here with another design you can hold down a round bar with the same block. We can use V block with the help of vise as well. So V block inside the vise, and that's how you can hold down to a round stock bar. Other method could be holding your workpiece directly to the machine table. So there's a open machine table. You can just hold this metal plate directly to the table through these clamps. These are called step clamps, and this is a set of step clamps. The way they work is that we can use different lengths of studs, these studs here, and then attach a T-nut. T-nut is here to it, and then this will go into the machine slot, and then we just tie a nut on the top. So in the next image you can see the assembly. So there's a step, and there's a clamp, and that's my workpiece here. So as you can see, if the workpiece is taller, I will need a taller stud here. That's how different size of studs come into play. Once we have our work holding device on the machine, the next thing is going to be that we should align it. So for example, if I'm using this vise, the vise need to be aligned with the machine slots, machine table. So if the slots are running in x-axis, this jaw should be perfectly aligned to that. So the way we do is that I hold this instrument to the spindle and then move the table around. When I'm moving the table around, the vise will move, but this test indicator will not move. And it will only be pushed or pulled depending on the jaw of the vise, how it is sitting. So that's how we can read how much out it is. And then we can adjust, just loosen these screws and rotate the vise a bit until we read 0 on both ends of the vise. The next step is going to be to set the origin. So if we want to machine this block and we want to do these holes in there, we're going to be just drilling them. Then we need to set, for example, this corner as our origin. So if I'm starting from here, we should be drilling at 0.25 inch and then 1 inch and so on. So this corner needs to be set as the origin. So what we do is we will somehow measure where this corner is sitting, and then give that information to machine control system so that the control can understand that where this workpiece is sitting in the space on the machine. And next step, we'll set up all the tools what we're going to be using. So we set up in the holders, drill bits, end mills, and so forth and so on. All the tools need to be set and put aside. Now one problem we have is the tools are different lengths. As you can see, this is a shorter, that's a little bit more longer, and this tool is way longer than the first one. So while we are working with them on the machine, we need to compensate for their lengths. So how we do that is that I will insert one tool in there. Usually there's a button here which we push it to clamp this tool in. Once the tool is clamped, what we do is we bring the tool down to this gauge, we put it on the gauge, and while it reads here 0 on the gauge, then we just go and see on the control system whatever dimension it says on the digital readout. We will just note that down. And other ways of doing is that some machines have this automatic probing system where the tool will come, touch the probe, and measure it. Once we have measured the tool, what we're going to do is that all that information what we noted down while we are measuring the tool, it will go here. So as you can see, tool number 1, 2, 3, 4 here. In front of each tool there is number. That is the number what we just measured it on the machine, and we will give it here to the control system, and that's how the control will understand that how the tools are different in length. And then all the tools will go here in the tool changer. You can see here on the side of the machine, and that's just exploded view there. So that all the tools are here, and now through our program we can call each tool whenever we want to work with it. Next step, we will just call our program. So most likely the program will be done off-site. Here this control has a flash drive on the side, so just insert your flash drive, call the program on the machine, and then we are ready to run. So while we are machining it, a lot of time you will see we use this white coolant, which is oil-based water, basically water and oil mixture, so that it takes the heat away and the machine doesn't get rust. This is an example of an engine block being machined on one of these machines. Here's all the references. And here's an example of a cam system, that how we machine what we wanted to machine. Thank you.